There are some incredibly well-built storage platforms like TrueNAS Scale that allow you to take your own hardware and turn it into a complete turnkey storage solution that takes all of the complexity out of building your own storage server by hand. I use TrueNAS Scale for all things storage in my HomeLab, and it's great, but it got me thinking, could I build my own complete storage system myself, and what would that even look like? So let's find out. Hey there, HomeLabbers, self-hosters, IT pros, and engineers. Rich here. I'm going to make a bold statement. I think that we all take software like TrueNAS Scale, Unraid, Open Media Vault, Sigma NAS, Rockstore, and others for granted, and it got me thinking, can I build my own storage system from the ground up using individual software packages available? And since I have yet to push my new storage system into production yet, why not try, take you guys along with me, and at the end, give you my final thoughts. One more thing, guys, this is going to be a journey. I expect to make mistakes, and I expect to screw some things up. Follow along at your own risk, and don't hesitate to tell me in the comments where I screw up, what I'm doing wrong, or what I could have done better. I think the best place for us to start here is with a list of the features that my bespoke, small batch, hand-built server should have. Let's figure out what features this server should have. Since I'm trying to make this system compete as much as possible with the other established storage platforms available on the market today, let's go over what it should be able to do. The first and most obvious feature is going to be file serving. What good would a storage server that didn't serve files be? So my system needs to be able to serve SMB and NFS at a minimum. Next, if I'm going to compare or compete with the TrueNAS Scales and Unraids of the world, I need to have virtualization functionality. So we'll need to add that. Along with virtualization, it would probably be wise to be able to run containers as well. So we'll be adding the ability to run containers to the list. With all the services out of the way, we need to make sure that my homebrew storage server has all the general functionality to manage it installed as well. Because my physical hardware has 24 bays and no RAID card, I want to make sure that it has the ability to utilize ZFS for data protection, snapshotting, and performance. I'll want some way to view or monitor all the temps and sensors that are embedded in the hardware, so we'll need something for that. And the biggest thing here, a GUI. This thing needs a graphical user interface. Yes, I know we can just manage all of this with the command line, but really, if I'm going to try and compete with the other storage software that's out there, I need to be able to manage it from a web interface. Alright, that is a pretty good list. Let's move on. Features defined, I think the next step here is to decide on an operating system. Obviously, this thing was going to run Linux from the get-go, but which distribution should I use? Choosing your favorite Linux distro is like choosing your favorite pizza toppings. I think pineapple belongs on pizza, and you might not. And likewise, some people like Arch, and that's fine. I have always been a heavy user of Debian and Ubuntu, so naturally, Ubuntu Server is my OS of choice. And of course, I'll be using 2404 LTS because I want the 5 years of security updates that come with it. By all means, tell me in the comments what distro you'd choose and why. Now that we've got the OS decision made, let's start filling in the other packages we're going to need for the system. For SMB, we'll obviously be using Samba. For NFS, we'll be using NFS Server. For virtualization, we'll be using KVM and QEMU. For containers, we'll be using Podman. For ZFS support, we'll install ZFS utils. And to monitor thermals, we'll install LM sensors. And for the GUI, yes, let's talk about the GUI. I spent a lot of time really thinking about the best way to decide on which GUI would best suit my artisanal, bespoke, small batch storage server. There are a lot of ways you could take this, but collectively I think it boils down to two different approaches. A single pane of glass to rule them all like you get with TrueNAS Scale, Unraid, and others, or death by 1,000 cuts of different individual GUIs and portals for each component of the system. Honestly, I don't know which is the right approach. Both have their advantages and disadvantages. You could make the case that there are very limited options for a single pane of glass management GUI in Linux compared to having a variety of very specific dedicated management GUI options for each individual service. Again, I'm trying to build my own storage system here that takes its inspiration from the established storage systems out there already, so I want to go the single pane of glass route. This means I really only have two options that I know of to achieve this in Linux: Cockpit and Webmin. The Cockpit project is an open-source, web-based server management tool that originated in 2014 as part of Red Hat's efforts to simplify Linux server administration. Designed to provide a user-friendly interface for managing servers in real time, Cockpit allows administrators to handle such tasks as monitoring performance, managing storage, networking, services, and even containers without needing extensive command line knowledge. It was initially created only for Red Hat-based distributions, but has since expanded its compatibility to include other Linux distributions like Debian and Ubuntu. Built to be lightweight and modular, Cockpit enables extensions for additional functionality, making it highly adaptable. As of today, it remains an actively developed and widely adopted project with strong community and enterprise support. Webmin is an open-source, web-based system administration tool that was first released in 1997 by Jamie Cameron to simplify Unix and Linux server management through a browser-based interface. It allows administrators to manage various aspects of a server, including user accounts, DNS, file sharing, databases, and software packages, all without relying on command line expertise. Written in Perl, Webmin is highly modular, enabling users to extend its functionality with additional modules or customize it for specific needs. Over the years, it has grown to support a wide range of Linux and Unix-based systems, becoming a popular choice for both home users and enterprises. If you know of other web GUIs for management, by all means, I want to know what they are. For better or worse, these two projects are the only two real single panes of glass GUIs that I am aware of. So the question becomes, which one is right for the job? Let's quickly go over some of the highlighted differences between these two GUIs. Cockpit is written in C and uses HTML5, JavaScript, CSS, React, and Patternfly for the front end. Webmin is written in Perl 5 and uses HTML, JavaScript, and CSS as well. Both have a modular framework where you can add additional functionality to them to extend their capabilities. Both feature basic core administration functionality out of the box, like patch management, service management, network configuration, and more. Both platforms are open source and are active projects that are well maintained. Both platforms look nice, and they're clean and easy to navigate. Both platforms support Debian and Ubuntu natively. In terms of advanced services out of the box, Cockpit lacks the ability to manage advanced services like bind DNS, mail, or database services without additional tools. Webmin has more advanced services it can support out of the box with native modules for DHCP, DNS, mail transports, and a lot more. For the most part, the list of features is nearly at parity. So, which GUI am I going to deploy? I'm going to deploy Cockpit, and here's why. One, I personally like the UI of Cockpit over Webmin because I think it's a bit more modern and lightweight. Two, Webmin doesn't have a module for ZFS, and since I'm using ZFS for storage, that's a necessity. Three, hands down, Webmin has far more standard and advanced modules out of the box than Cockpit, but this is a storage server only, and I don't benefit from having a module for DHCP or bind DNS and so on. And there's one more fact here that leans into my decision. Cockpit has modules freely available that are made by 45 drives that I want to take advantage of, things like a module for ZFS storage management. And with that out of the way, I think it's time to build the system. I'm going to walk through this with you step by step, from OS and package installation to module install and config to storage deployment. Any snag I hit along the way, I'll call out, or you can skip to the end and get to my TLDR and final thoughts. Let's do this. The first bit of this install is going to be happening via the IPMI interface of the server, so I can capture the initial install process of Ubuntu Server 2404 on the host. After that, we'll do everything via SSH. I won't bore you with the mundane details of installing Ubuntu. I booted off Ventoy, launched the 24041 live CD, and ran through the setup. Everything was fine until I got to the disk configuration. I have two 480GB Intel SSDs in the back of this host that are there for boot functionality only. So, obviously, I wanted them to be a RAID 1 mirror for redundancy. However, for the life of me, I couldn't figure out how the hell to set up an MD array as a boot disk for Ubuntu. And it turns out, after a lot of searching on the internet, the short answer is, you really shouldn't do that with MD and Ubuntu. So I said screw it and moved on. I am disappointed that building a software mirror during the install process wasn't something that I could figure out. I have seen articles online where people have figured it out, but the collective wisdom on the internet is something to the effect of, just because you can doesn't mean you should, so I moved on. As an aside, you can easily do this in TrueNAS Scale on install, so there's that. One more thing, if you watched the first video I did on the system, I threw out a call to everyone watching to help me choose a name for the server, and there were some really good suggestions, and in the end, I settled on Ultrasan. Anyway, OS installed, let's get the second phase of this going. Let's get all the things we decided earlier in the video installed and set up on the host. I'm going to bounce through this relatively quickly to save you time, but I will show you the commands I'm running, and I'll make sure to provide a link to them in the description to our website if you're following along. Let's get to it. All right, let's get logged in. This is the first time officially logging into this freshly minted server, so of course my client doesn't trust it. We'll type in yes and hit enter to move on, and then I'll type in my password. The first thing I do when I log into a fresh installation of Linux is to update the entire system before doing anything else, so I'll sudo as root using sudo-i and enter my password, and then use this command. This command updates all of the package repos on the host, installs all waiting updates including kernel updates, cleans up after itself, and then reboots the system. After a brief interruption due to rebooting, we'll get logged back into the system and again issue a sudo-i to elevate my console to root privileges. I think the first place to start here is with the Cockpit GUI. It doesn't have any dependencies on any of the other packages we're going to be installing, so we'll knock that out first. We'll use the command apt install cockpit-y and hit enter to install it. One more command to finish out the Cockpit install. The command systemctl enable -now cockpit.socket makes sure that Cockpit starts up with the system every time it reboots. Alright, all done with that, let's just double check to make sure it's working. We'll pop open a browser and enter in the URL to the server at http://172.241.39090 and hit enter. Boom, there it is. We can log in just to make sure all is well. And it all looks good. I don't want to spend too much time in here just yet, since we have a bunch more stuff to install, but the TLDR is that Cockpit is up and running. Moving on. Now let's get ZFS utils installed on the host. To do this, we'll use the command apt install zfs utils-linux-y and hit enter. ZFS utils provides the user space utilities to manage and use ZFS. It includes essential tools and utilities for creating, configuring, maintaining, and interacting with ZFS. Next, we'll install Samba. The command we'll be using here is apt install samba-y. Samba provides SMB network file serving functionality. SMB is the file share protocol used by Windows and is necessary for making network shares available from the storage server to the rest of the network. Along with Samba, I wanted to provide NFS shares as well, so we'll be using the command apt install nfs kernel server-y. NFS, or Network File System, is a file sharing protocol used primarily between Linux and Unix systems, and you see it used a lot less these days. I use it for mounting file shares between my Linux VMs like Nextcloud and Plex. ZFS utils, Samba, and NFS are really the core file system and file sharing packages we need to create a file server. Everything else we're about to install from this point on is more about creating a feature parity between turnkey systems like TrueNAS Scale and Unraid. Now let's get virtualization support installed and configured. Here's the next command. Apt install qemu-kvm, followed by virt-manager, followed by libvirt-clients, followed by bridge-utils, followed by libvirt-daemon-system, followed by virtinst-y. This string of multiple packages will install kvm, qemu, virt-manager, and the other supporting packages we'll need to run virtual workloads on the server. Now that's done, we need to enter the command systemctl enable libvirtd, which will configure the host to start kvm on boot, which will be necessary if we want any of our virtual machines to boot when the host boots up. We're not quite done with the virtualization commands though. We'll need to add my user to 2 groups on the system so I can create, manage, and maintain VM workloads. The first command is usermod space -lowercase a capg libvirt followed by my username, and then enter. And the second command is usermod space -lowercase a capg kvm and my username, and again enter. Alright, all done, let's move on. One more big feature to add to match all the turnkey storage systems is something to run containers. To install Podman on our host, we'll type in apt install podman-y and hit enter. We're using Podman over Docker because Cockpit only supports Podman, so that kind of forces our hand. But Podman isn't any less functional than Docker, and the commands effectively are the same, so we're good. Alright, one more thing we can do really quickly related to Podman. We can enter in apt install cockpit-podman-y and hit enter. This installs the Cockpit module for managing Podman in Cockpit, so we might as well do that now. One more package to kick in this round, and that is LM Sensors. We'll type in the command apt install lm-sensors-y and hit enter. LM Sensors is a Linux utility that monitors hardware health by providing information about various system sensors such as CPU temperature, fan speeds, voltage levels, and other related metrics. I want to be able to see the thermals and health in Cockpit, and LM Sensors is how we'll do that. Now that LM Sensors is installed, we need to quickly configure it. We'll type in the command sensors-detect and hit enter. Sensors Detect is a command line utility included with the LM Sensors package. Its purpose is to detect the hardware monitoring sensors present in the system and generate the necessary configuration for LM Sensors to read data from them. We'll say yes to all these prompts and then yes to updating the config file. Let's quickly jump over to Cockpit to make sure everything is looking good. Logging in, we can see everything looks functional, so let's continue with the installs. Phase 1 installs out of the way, let's talk about what's next. In terms of Cockpit, we really only have it and the Podman module installed, so now we need to finish up the rest of the module installations. This is the list of currently available modules or applications as they're called for Cockpit. There are a lot of them. Some of them, like the storage, network, and software updates applications, are installed with Cockpit by default, so we won't need to add those. But we definitely will want to add the virtual machines application for controlling and managing VMs, the diagnostic reports, because why not? And then further down we get to the good stuff from 45 Drives. 45 Drives has a dedicated ZFS Manager application for Cockpit, which we'll definitely add. We'll also add their file sharing application for managing Samba and NFS shares, and their navigation application to get a nice graphical file manager. There's one more application not made by 45 Drives to give us graphical access to our LM sensor data, so we'll add that too. As an aside, there are also applications for tail scale, head scale, and Cloudflare tunnels if that's something you're looking for as well. We'll be skipping those and focusing on the list previously mentioned. Let's get everything installed. Alright, let's get the rest of the modules installed for Cockpit. Let's start with adding the virtual machines application to Cockpit. We'll use the command sudo apt install cockpit-machines-y and hit enter. Now that's done, we'll install the SOS report application. We'll enter in sudo apt install cockpit-sos report-y and hit enter. Perfect, now let's get the 45 Drives ZFS application installed. Based on the install documentation on their GitHub, we'll need to pull down the project using git and then copy the data over to Cockpit. So we'll enter in the command git clone followed by this URL and hit enter. Now we need to move the data we just copied locally over to its final location on the file system using the command sudo cp-r cockpit-zfs-manager/zfs/user/share/cockpit and hit enter. ZFS Manager is now installed. Alright, next is the 45 Drives sharing application for Cockpit. We'll first be running the command curl space dash lowercase s cap l followed by this URL pipe sudo bash and then hit enter. This command will add the 45 Drives app package repo to our system, making it a lot easier to install much of the 45 Drives software and also allowing us to get automatic updates when 45 Drives pushes them out. Now that's done, we need to run an apt update to update our host's package list since we've added the new repo. Alright, we're ready to install the 45 Drives sharing application. So we'll toss in this command, sudo apt install cockpit-file-sharing-y and hit enter. In addition to the 45 Drives file sharing app, the project also recommends installing the 45 Drives Identities app as well. So we'll do that by entering the command sudo apt install cockpit-identities-y and hitting enter. Just 2 more apps left to install. Next is the final 45 Drives app called Navigator, which provides a really nice file manager for Cockpit. We'll enter in the command sudo apt install cockpit-navigator-y and hit enter. Alright, that's all the 45 Drive software. Our last application is the LM Sensors application. This big block of text downloads the LM Sensors app for Cockpit, then untars it, then moves the data to the correct location for Cockpit on the file system, then cleans up by deleting the untarred directory and files, and then finally deletes the downloaded tar archive. We'll hit enter and kick this off. Alright, from this point, everything I can think to install is installed. Alright, here is the dashboard for Cockpit. We've got a few cards on the right for system health, usage, system information, and configuration. On the left, in the navigation pane, we have a bunch of additional sections that weren't there before. Let's tear through them really quickly. Logs gives you a place to view syslog events that have happened on the host. At the top of the window, you can filter on time and priority. Pretty straightforward. ZFS is the 45 Drives ZFS Manager application we installed a bit ago. First time opening the app, we're asked to set initial configurations. I'll leave it as is and click Configure. Alright, there are no storage pools found because we haven't built any yet. We'll get to that later. Moving on. Storage is a built-in Cockpit application that provides visibility into all of the storage devices on your system. You can also create partitions, MD arrays, and so on. Unfortunately, the one thing you can't do in it is create ZFS pools, hence why we have the 45 Drives ZFS Manager app installed. Next, networking is for all things networking on your host. You can change address configurations, build bonds, teams, add VLANs, all the typical stuff you'd want or need in terms of network management on your host. Podman allows me to create and manage Docker containers, so that's there, which is great. Next is virtual machines, which allows me to provision out storage pools, configure virtual networks, and build out VMs on the host. Accounts is a built-in Cockpit application for managing local users, groups, and access rights on the box. Services is another built-in Cockpit application for managing services on the host. Navigator is the 45 Drives file management application we installed. This gives you the ability to do more basic file management functionality on the host via Cockpit, like upload, download, rename, copy, move, delete files, and folders from the host. File sharing is another 45 Drives app we installed just a bit ago. It provides a GUI way to manage SMB, NFS, and even iSCSI shares from the Cockpit GUI. Identities is also a 45 Drives app we installed. It provides you with another way to manage local users and groups on the host, and also provides you with a logon history at the bottom. Down below in Tools, we have an application section that for some reason only includes the Cockpit's project's own applications and none of the others we've installed. All the entries here are also directly represented in the left navigation pane as well. Diagnostic reports is apparently broken, so that's cool. Sensors shows us all of the dedicated sensors on my host. It allows me to convert Celsius to Fahrenheit because I'm a lazy American, and expands out to show me a lot of detail about current temps, max temps, and critical temp limits for my CPUs and other thermal sensors. And it also shows me my current power draw on the host, which is great. I am always asked in the comments of my server videos, how much power does this host consume? And the answer is an average of 254 watts. There it is. Software updates is also, apparently broken, so we'll need to figure that out since that's kinda a critical thing to have in the GUI. And finally, terminal is just that, access to the command line from the web GUI. Cool. So for the most part, things are functional with the exception of the SOS reports and getting access to software updates. Before we attempt to troubleshoot the update issue, let's see about getting a ZFS pool built for storage using the 45 Drives ZFS app. In the ZFS application, we'll head over and click on Create Storage Pool to get started. Looking at this window, I can instantly tell that we're very light on using the advanced features of ZFS. It looks like via this GUI, the best thing we can do is just create a single volume. Let's run through it. First off, we need to give the pool a name, so I'll call it Big Pool. The next step is to decide on which level of protection we want for our data VDEV. We've got all the standard hits here: disk for single drive, mirror for disk mirroring, and RAID Z1 through Z3. Noticeably missing here, I don't see any options for special VDEV types like log, caching, metadata, and so on, which is a bummer. I'll leave this set to RAID Z2 for 2-disk redundancy and move on. The next step is to select the disks to add to the pool. There's no way to select all the drives that I can see and then deselect the ones you want, so you'll have to go through them one by one and select them. You do have some configuration options to make about the pool, like sector size, record size, deduplication options, and a refreshervation? That feels like a typo. You guys tell me if I'm wrong. I do like that you can also set options like auto expansion, auto replace, auto trim, and so on. I'm going to select automatic trim since these are SSD drives and I want them to stay fast. Let's create this pool now. ZFS pool creation was easy enough, however, I'm bummed you don't have any options in the GUI for creating additional VDEV types. If I'm being honest, I don't use any special VDEVs in my production storage anyway, but I know others that do, and you can do this in TrueNAS Scale. Don't get me wrong, I know you can do all this via the command line using ZFS utils and whatnot, so it's not like you can't actually do it at all, just not through the app that I've installed for Cockpit. Oh, and one other thing, I didn't show it, but the ZFS app also allows you to create standard datasets once you've created your pool, so you can carve up your pool as many ways as you'd like to organize and segment your data. Now, let's try to figure out what's going on with the updates. The error I'm getting was cannot refresh cache whilst offline. So the first thing you do in a situation like this is copy the entire error message from the screen and go to the Googles. Searching for the error on Google netted me some useful answers. The answer to the problem for me was found on Reddit because, well, of course it was. And the answer was, I needed to add the line renderer:network manager to fix this, so let's do that now. SSHing back into the host, we'll type in the command sudo nano/etsy/netplan/50-cloud-init.yaml and hit enter, followed by my password since I need sudo rights to edit this file. Your cloud init file might have a different number in the file name, so don't be surprised if yours is a 10 or something like that. Alright, this is the network configuration for the host. We need to add our line at the bottom, so we'll head down below the final line and paste it in. YAML is very structured, so make sure you make the start of the statement align with the start of the last line as well, or it might not work. All done here, let's hit Ctrl-O and press Enter to write out our changes, and Ctrl-X to close Nano. I'm going to reboot the box now using the command sudo reboot, let it come back up, and see if that fixes our issue. Now that the host is back up, back into Cockpit, I notice that we have an error under Services. Looks like our changes caused systemd-networkd-wait-online to fail to start. Another search on the net states that's expected behavior, and we can disable that service from starting on the box. It will have no impact on the system. Let's check on software updates now, and it looks like it's working. That wasn't too hard to fix, but it'd be really nice if it wasn't an issue to begin with. I'll go ahead and kick off updates by using the Install All Updates button at the top. Updates ran for quite some time, got most of the way through installing, and then blasted me with yet another error message. This time, something related to being unable to overwrite a JSON file that coexists with another package. A refresh of the page shows that most of the updates were installed as expected, including the security updates, and we have a few left over from the previous attempt. I'll try again, and failed again. Something for me to troubleshoot on the containers common package. Super. One last thing before we close out the video. Let's set up an SMB share and make sure it works for storing data. Inside the 45 Drive sharing application, our first stop is to click on the plus in the sharing configuration section. We need to give our share a name, so I'll use Big Pool. Next, we need to provide the path on the file system that we'd like to share, so I'll enter in /bigpool and select it as well. For the sake of simplicity, we'll enable a few permissions. First, we'll enable guest OK, then inherit permissions, and click Apply. Boom, just like that, we're done. Let's check to make sure we can see the share in Windows and create a folder in it. Alright, I'm on Windows 11 here, and I've used the UNC path of 172.24.1.3. Your IP address for your host will likely be different. I can see the new share we just created called Big Pool. Let's enter it and make sure we can create data inside of it. We'll right-click and add a new folder, and name it Hello. Perfect. Everything's working. One last stop, let's take a look at the folder using the Navigator app in Cockpit. Back over to the GUI, we'll head up and click on Navigator. Now we'll open Big Pool, and we can see my created folder. We'll right-click on it and delete it, and we're done. I'm not going to continue to troubleshoot this with you guys on here because it's just kind of painful to watch. Based on the functionality that's up and running though, we've completed our GUI, storage, sharing, monitoring, and so on. So let's talk about how I feel about doing this. Up front, I'm going to tell you this kind of sucked. Was I able to build a storage server from the ground up using individual package installations and have a functional storage server? Yes, absolutely. Is it anywhere near turnkey like Scale or Unraid? Absolutely not. Did I learn things? Yeah, I certainly did. Let's talk about what I learned. First, I learned that it is a nightmare to attempt to create an MD mirror for a boot install in Ubuntu server. That was a bummer. Thing is, what you guys see here on the screen is only a snippet of like 45 minutes plus amount of effort that I went through trying to figure that shit out. Attempting, reading, reattempting, researching, just to find out that the general consensus is that you probably shouldn't do this thing anyway. Being as I spend most of my time working in virtual systems, I honestly never think twice about redundancy at the boot level because it's a non-issue in virtualization. But I feel like it's critical for physical hosts, so I'm not sure why it's not easily baked into the install process for Ubuntu. By the way, this is something that you can do trivially in TrueNAS Scale in the install process, so there is that. Secondly, I don't feel like I was able to achieve that true single pane of glass GUI that I had imagined in my head. Sure, I got what I needed in there for the most part, but it's not the ideal solution that I was imagining. And to be honest, at best, it's just meh. Third, and this will probably be a controversial opinion here, but cramming all these different features into creating this all-in-one package and then having to deal with broken updates with Podman containers just reminds me why shoving everything together in a single Linux box kinda sucks. And it also really makes me appreciate what we get from the turnkey solutions out on the market. The big benefit in using something like Scale, Unraid, or Open Media Vault is that there are people working behind there to make sure that everything just works and that updates happen without issues for downstream users. Don't get me wrong, I'm fully aware that things break in those platforms as well. I've had my share of BS in TrueNAS, believe me. But I know they'll get fixed, and the best part is I won't have to do it. So, final thoughts here. If you want to endeavor to do something like this, go for it. Maybe my experiences will help inform yours, or maybe not. Or maybe you don't care about a GUI, and that's cool. I respect that. In the end, though, this really has been a good reminder not to take those projects for granted. They're doing a good job at overall making all of our lives easier in the home lab. And that, friends, will do it for this video. If you liked it, throw us a sub and a like, and if you have a beef with anything I've said here, let me know in the comments below. Special thank you to our YouTube members. You guys help keep the lights on, and we thank you for it. If you'd like to help support the channel, consider becoming a member or buying some of our swag. It'll help us keep making these videos. And now that you've finished watching this video, how about checking out this place over here of other great home lab videos we've done in the past? If you're looking for your next great home lab idea, we can help.